Suppose that you have 9 cards. 5 are green, 4 are yellow. The 5 green cards are numbered 1 through 5, and the 4 yellow cards are numbered 1 through 4. The cards are well shuffled, and you randomly draw 1 card. So G means you draw a green card, Y means you draw a yellow card, and E means you have drawn an even numbered card. And we're going to round all values to 4 places. So in the first part, it says find the probability that you draw a green card. I drew a visual representation of these cards down here. I personally am a very visual person, and when I draw things out, I find that it really does help me. So for those of you who are visual, I think this is really going to help you. So we have 9 cards in total, and we need to find the probability that we choose a 1 green card. Well, there's 5 green cards out of a total of 9. So we would take 5 over 9 and then, of course, put it in decimal form. And so that would be 0.5556. So let me write that down. So this would be 5 out of 9. And then we put that in decimal format. That would be 0.5556. Now, part B says, find the probability of choosing a green card given that the card is even. So that means we're only looking at the even cards. What is the probability of picking a green card out of the even cards? That's what this is saying. So here's an even card. Here's an even card. Here's an even. Here's an even. So we have 4 even cards. Those are the ones I just circled. Out of those even cards, what's the probability that I'm going to choose a green card? That would be 2 possibilities out of the 4. So that would be 2 out of 4, which would be 0.5 when we put it in decimal format. So let me erase this. Okay, next example, part C. Find the probability that we choose a green card and a yellow card. Since we're only picking 1 card at a time, and it says here in the problem, you randomly draw 1 card, okay? Since we're only drawing 1 card, the probability of picking a green and yellow is 0. It's impossible to pick both a green and yellow card if we're only picking 1. So that would be 0. Find the probability that we pick a green and an even card. So out of all of these cards, we've got to look to see how many are green and even at the same time. So here's one that's green and even. Here's one that's green and even. There's no other green and even cards, so there's 2 out of a total of 9. So I'm going to take 2 divided by 9. And that's going to give me 0.2 repeating, but when we round it to 4 places, that's going to be 0.2222. Now, I didn't narrow down and pick it out of a certain subgroup because it didn't give me a given assumption. Unless it says, like in example B, the probability of picking a green given that we already picked an even one. So we know that in this one, we're taking it out of the even cards because that was the given assumption. In all of these other ones, it doesn't say given. It doesn't have the symbol for given. So we're taking it out of the entire group. We're not narrowing it down. We only narrow it down when it gives us a given assumption. Okay, so part E says, find the probability that it's green or even. Well, here's all the green ones. So that's 1, 2, 3, 4, 5 out of 9. Those are all the green ones. So the probability of picking a green is 5 out of 9. Now, if we pick an even, let me use a different color here. I'll use, I don't know, I'll use blue. Let's see, if I pick an even one, that would be 2, 4, or this 2 and 4. Those are the even ones. So I have 1, 2, 3, 4 out of 9. So the probability of picking an even card is 4 out of 9. However, some of those cards I double counted. I double counted these ones here twice. I counted them in the group that was green, and then I also counted them in the group that was even. Because I counted those two cards twice, and I don't want to double count anything, I have to subtract that probability. So that was 2 out of 9. I don't want to count that probability twice. So this is where you have to subtract the overlap. You don't want to double count. So I'm going to take 5 over 9 plus 4 over 9 and subtract 2 over 9. And when I put that in on the calculator, you should get 0.7778. Part F says, since G and E is equal to, where is G and E? The probability of G and E, that was part D right here. And we said that that was 0.222. So since that was, whoops, I can't do that drop down menu because this is a picture. So your options here would be that it's equal to 0 or not equal to 0. So in this case, I would pick not equal to 0 because 0.222 is not equal to 0, which means G and E are not mutually exclusive. Mutually exclusive means that the probability of them happening together is 0, meaning they can't happen together. G says the probability of G and Y, meaning the probability of picking a card that is green and yellow, is equal to 0. You can't have a card that is green and yellow in this case. You either pick a green one or a yellow one. Because they cannot happen at the same time, we would say they are mutually exclusive.